Today, we are going to briefly discuss the effects and use of UAVs in EMI, EMF environments and the importance of a dielectric or non-conductive frame and the ASTM 711 process used for testing. Most of you may already know what it is meant by EMI, EMF fields and are likely aware of the effects that can occur. But I would like to quickly define what it is for anyone who is not aware of it, what exactly EMI or EMF stands for. In short, electromagnetic interference or field is the simple definition for EMI or EMF. These fields are created in and around power lines, substations, communication towers, and even in the natural magma displacement in and around volcanoes and other natural or man-made created environments. The higher the voltage and current, the greater the EMI or EMF field becomes and extends out further from the source. This graph you see came from the information gathered in a scientific study of the EMI EMF impact from a 300 kV power line. As you see, the EMI EMF field reaches out as far as 1,000 feet or 300 meters. The higher the voltage and the current, the larger the field and the higher the EMF impact becomes, and it increases exponentially as you approach closer to the source. It is for this reason the UAV community is advised to keep a safe distance so that communication and orientation between the UAV and ground station is not interrupted, which can lead to a catastrophic failure event. UAV technologies have been limited in their ability to resolve this issue. Thus, in some cases, the pilots are taking risks by operating too close to the EMF source, such as power lines or substations. This has resulted in damage not only to the drone itself, but has caused damage to costly electrical equipment, transformers, switching, and substations. These incidences also cost the utility company tens and sometimes hundreds of thousands of dollars in repairs and lost revenues from interrupted services to customers. This list highlights just some of the challenges faced when operating a UAV too close to the asset or facility. Another issue to consider is that the use of the drone itself is limited from other possible uses that could otherwise be performed safely when in close proximity to the EMI EMF source. Here's a question. Can you currently deliver a tool to a lineman using a drone as the delivery method rather than a rope or pulley bucket to do it safely? Most drones simply can't fly this close to assets or workmen to perform a task of this type. This is just one example, but there are many more that could be discussed. The Meadowhawk is a result of a culmination of thousands of hours of design, testing, and user feedback to create the ultimate utility drone platform. Built and tested to meet and even exceed the ASTM 711 standards for hot sticks used by linemen, the Meadowhawk uses a completely non-conductive material for its dielectric frame and body. While carbon fiber is an excellent UAV airframe material for most applications, it poses the issue of being a highly conductive material. At the request of our clients, we've developed an ASTM F711 rated frame. This allows crews to get much closer to high voltage installations without the concern of a downed aircraft shorting out the grid, minimizing liability, and increasing safety. Union Robotics is a company that focuses on the need for non-conductive unmanned systems. The design not only works well within the EMI EMF fields, but in the event that an incident did occur, the airframe and body will not become a damaging conductor to the equipment it is operating around. Because it is non-conductive, many operations that require powering down the line or substation can now be performed while the asset is still hot. Working with field engineers from PG&E and other critical development partners, this UAV is designed and engineered to be lineman tough. The next video clip discusses the ASTM F711 testing process and the requirements to meet the standard. Let me introduce you to Chris Shipley of HJRNet Industries. After meeting Chris, you will have the opportunity to meet the key members of Union Robotics team and hear what they have to say about the product development and the benefits of a dielectric UAV. We invite you to chat with us during this presentation and/or contact us directly with your questions. Thank you so much for your attendance today, and we look forward to meeting everyone.
Hello, my name is Chris Shipley with RNet Industries. We're a dielectric test lab, testing and performing examinations and inspections for electrical PPE, hot sticks, grounds, jumpers, rubber, protective insulating equipment. And we did some tests for Union Robotics and their new drone, their new products that they're using. And just want to cover a little bit of that process. We test, as you can see behind me, some of the sticks. They're fiberglass sticks, so the Union Robotics is using their material, their paint. We're following some of the standards that are ASTM. We are doing a dielectric test at 50,000 volts, and then we ramp it up for some of their products. So 50,000 volts at 6 inches for the duration of the tool is the goal. So the high voltage coming in here, 50 kV. I'm seeing milliamps of leakage there.
Yeah.
Like for instance, on the gloves, when we test those, a rubber glove, the milliamp leakage there could be 16, and that would, over that is the failure point of an actual primary piece of protection. That's the only piece of protection that actually has a failure point for leakage. So most of them are just kind of a measurement that there is some voltage going on, the test is being conducted properly, and if there's no flashover or that leakage isn't changing throughout the duration of the test, like I mentioned earlier, it should go down, should never rise. So if it was rising, then that would be a measurement of why is it doing that. Where is it heating up, burning up, is there a source of moisture in there that's warming up? Because it should just be dissipating for it.
Hi, I'm Jill Farr, Marketing and Information Officer for Union Robotics. I'm here with Zeke Biershank, our President and CEO, Jeremy Highhouse, Integration Engineer, and Ryan Cashin, our Operations Manager. Today we're going to answer the question, why dielectric? And we're going to discuss the advantages of using drones manufactured from non-conductive material for use in the energy industry. And we're also going to explain a little bit about our flagship product, the Meadowhawk DE, and some of the practices that we utilize and recommend for our energy clients. Now, first, there's the safety element. And Ryan, would you like to speak to a few of the many points that support non-conductive material use around high voltage assets, both in the energy industry and related sectors that have electromagnetic fields?
Well, first of all, I think that's something that we can all have a good idea and answer on, but for most applications, whenever you're dealing around high voltage lines, there's always a risk of electric shock. There's always risk of arcing. There's a lot of fall issues around working with towers and high voltage lines at high altitudes, off the ground, I should say, above ground level. So using our drones is very useful in the fact that because they're dielectric or non-conductive, they reduce the risk of an actual arc or transfer of energy from one product to another. The other thing it allows us to do is it allows us to fly close, in close proximity to those lines, and even go as far as being able to line poles, even deliver small tools to linemen who are up on high top of towers and so forth, without having to put a pulley system together, which is also another risk. So there's a lot of advantages, and there's so many more that we can go into, but those are the key elements as to using a dielectric drone that we manufacture. But drones in general can do a lot of these things. It's just that they can't do it in the close proximity that we can with our non-conductive material built drones. The other thing is we paint our drones. And the reason we paint our drones is because it adds another layer or level of protection in several facets. Number one is they're bright colors, So they're very high visible, the same as you'd see on a hot stick. Linemen will know what a hot stick is, and those of you who don't, it's the long pole that reaches out that they use to do switching on these stations. And so they're colored very brightly in yellow and orange and a bright electric lime green, safety colors. And so there's a reason we paint them for the bright colors, as well as the fact that it actually gives another layer of protection on the actual airframe itself from conductivity, because we use a type of paint that is also non-conductive, similar to what they use on aircraft in the aviation industry to keep lightning strikes from causing problems with instrumentation inside the aircraft. So we have another purpose for that. And then finally, it makes it easier to maintain the vehicle and keep it clean and keep it working and keep it strong. It supports the aircraft structurally by having that paint surface on there. And through the use of our, what we call shield wipes, it's a wipe down procedure that we recommend prior to flying and after you fly. And it keeps the aircraft clean and maintained well. And those shield wipes are also something that we've formulated specifically for the drone industry, whether they use it on our drones or somebody else's drones. They work very well, and they give it an extra layer of protection, a moisture barrier, if you will.
Zeke, let me ask this. I think that a lot of people may be wondering this. When we say just dielectric material, is all dielectric material created equal? I know that you could probably explain a little bit about the testing process and how we've really tried to ensure that our dielectric material has been safety rated so that people can look at it objectively and know that it's been tested. Could you explain a little bit about that?
So the material that we use, it passes the hot stick standards of ASTM F711, which we are able to run 50,000 volts through a 6-inch segment of the material. And we can actually run well above 90,000 volts of that same test.
That might be a good place to turn to Jeremy, our integration engineer, to explain how using a UAV manufactured specifically for the energy industry can increase productivity and reliability, especially as opposed to using a drone that has basically been taken off the shelf from, a hobby shop, or repurposing a drone that's been used, for non-industrial use. Jeremy, how can using dielectric drones increase efficiency and reliability?
Well, the main point being that you mitigate a very large chunk of your risk through the use of the dielectric material. But on top of that, we have spent a lot of time integrating many redundant systems into the aircraft that you won't really find on other aircraft in the industry, especially at this price point, that allows you to fly in high EMF and EMI environments without having to be concerned about your aircraft doing strange things like a lot of the other aircraft that are on the market might do in that kind of environment. We have done a lot of testing on the ground with linemen to ensure that our aircraft is ready for very demanding environments. One of the environments we flew in was between a 300 kV line and a 500 kV line that were separated by about 100 feet. And so it was just a very challenging place for most other aircraft to fly, but we were able to fly successfully, without any issues whatsoever, and get the pictures for the inspection. So another thing that plays into that is all the redundancy that we have built into our aircraft that makes it so you can fly it worry-free in those kind of environments. And even if one sensor isn't healthy, it will lean on another sensor using the customized firmware that's in the aircraft.
Jeremy, since you brought up sensors, I was just going to ask if you could tell our audience a little bit about the type of sensors that are currently used, how they're used, and some of the new uses that we've found.
Okay. The main thing is that the heart of the aircraft is the IMU, which is the inertial management unit. So that's what looks at the orientation of the aircraft. So if the aircraft is, tilting to the right or the left or front or back, etc., and that's how it flies. And so the IMU is triple redundant. So there's 3 of them in use at all times. And so it's always looking at which one is healthiest to determine the best sensor to use all the time. And then from there, it goes on to things like there's a redundant compass, as well as there's a flow sensor, which adds a really good level of redundancy to the GPS unit. We use a very high quality GPS unit that is quite expensive and you won't really find in consumer aircraft. And this one works great, but in the event that there is something that would cause some sort of a glitch, we have something called an optical flow sensor, and what it is it's essentially a small camera mounted on the bottom of the aircraft, and it works very much in the same way that your optical mouse does, looking at the pixel flow of the ground moving around. So you can actually fly with that sensor alone, but we use it as a backup essentially to the GPS. So if something else were to happen to the GPS, it will actually lean on that sensor so you can return to home safely and land your aircraft and not have a catastrophic event where you end up, in the power lines or in your substation or whatever asset you're trying to inspect.
Another point is that our payloads can carry a lot of different types of detection equipment, whether it's a high resolution camera with a 1-inch optical opening and a large zoom, whether it's using thermal imaging. We can get into multispectral cameras for certain particular uses. There's all sorts of sensors that are available that can integrate well with our aircraft. And we're finding that there's even a wider spread on what those uses are. It's been thought that a really good high quality camera is the only way to do an inspection because you can look up close and take photos. And now they're determined that there's other sensors out there that can give them a lot of information. The engineers can compile that information and come up with a lot better reality and conclusion as to the status of their equipment that they're inspecting, or the infrastructure, and whether it's power lines or oil lines, water lines, could be just even doing a GPS mapping or construction. There's a lot of applications for these sensors that can cross over from one field to the other. So the nice thing is that because we are highly engineered to work in these high EMI and high electrical environments, it crosses over to also work very well when those elements aren't there. And so it's a very, very stable aircraft in all aspects, not just in electrical fields.
Jeremy, would you like to speak a little bit to the biggest differences between conductive material and non-conductive material?
Well, in the setting of inspecting high voltage assets, the vast majority of aircraft you're going to find are made from conductive material. They're made from carbon fiber. And carbon fiber is a great material for aircraft. When you fly in an airliner, a lot of times it's made of carbon fiber, but it's not a good material if there's a chance that your aircraft could end up in a high voltage asset and short something out, take the grid down, something, that would ruin everybody's day. So our aircraft aims to negate that as much as possible by having a 100% dielectric frame. So the largest part of the aircraft can't, actually conduct electricity to a certain degree, of course, everything can conduct electricity, but this will resist that, to the ASTM F711 standard, same as a hot stick, so that you can fly closer into your assets for inspection, very comfortably. Talking with some of the people that we've tested with, they were using very high megapixel cameras because they needed to stay far away from the assets because they weren't comfortable flying close in the event of having the aircraft go down into the asset. There was a substation in this case. It's this really opens up a lot of opportunities to do inspections that were very difficult to do before, much more expensive, required larger aircraft, required larger sensors, et cetera, et cetera. And so that was our aim, because this aircraft was inspired by a substation manager who was like, I need an aircraft so that I can get close in on my substations and not have to worry about, something bad happening.
The other things I might mention is that as we've been going through this process of testing and going through the use case scenarios with the utility industry, we've also had now some new interests coming from the scientific community. And this might be just as a little side note for those out there who are interested, is that even volcanology, the Earth Sciences divisions from the university and from the Mexican government have actually looked at our product to be able to use around and study volcanoes because of the high EMF fields that are created by the volcanoes themselves during an eruption. And they're hoping to use our product to help be better at predicting eruptions and size of eruptions and when they might happen, with some new sensors and technology along with our drones. So this is just a little side thing that has come up as we've been developing this high engineering for basically utility industry. It's now organically moving into other industries that they're finding a lot of uses for.
And I did want to mention that although this was designed for use in the traditional energy sector, that there's huge capability in non-traditional forms as well for use around wind turbine, solar energy. Is that correct?
Yes, in fact, actually, we have several case studies that show that the use of our product works very well around almost all energy sectors in different aspects, depending on the type of camera or detection device or data collection device you need to use. But because it is so robust in its engineering, it works very, very well across the board in all sectors.
I hope this has helped our audience understand the benefits of using drones that are manufactured with dielectric material for use in the energy industry. If you have further questions, you can always take part in our Q&A, or you can email us at info@union-robotics.com. We're always happy to inform and interact, and we'd love it if you'd follow us on social media or take a look at our website if you'd like to learn more. We are a robotics company that's focused on people first and foremost, and our primary mission is the safety of human personnel, and that's followed closely by our goals of increased productivity and profitability for our clients. We believe that drones provide the means for achieving all of those, and we believe that dielectric drones are the highest level solution. So thank you for watching, and we look forward to interacting with you more.